Hello everyone. Now I'm very glad to have the opportunity to share our work, ScalerEval, Automated and Consistent Evaluation Testbed for Autoscalers in Microservices. Autoscaling is a technology that's designed to ensure the performance of microservice systems. As the workload increases, the microservices may encounter a performance degradation. We can scale specific microservices to deal with this. For cloud providers, on the one hand, they want to reduce resource cost. On the other hand, they must provide sufficient replicas to meet users' service level objectives. The evaluation process of an auto-scaling algorithm typically consists of 5 steps: benchmark initialization, scalar registration, workload injection, metric collection, and performance assessment. For the benchmark initialization, we need to start a system and configure the gateway for traffic management. For the scalar registration, we need to register a specific scalar algorithm and run it asynchronously. Subsequently, we inject workloads into the system and collect performance metrics for evaluation. Unfortunately, existing studies primarily focus on refining auto-scaling algorithms while neglecting the standardization and automation of the evaluation process. For example, there are many tedious efforts in building experimental infrastructure. We need to implement many fundamental functions, such as observability, workload injection, and operation. This process is complex and time-consuming. The second challenge arises from the complexity and error-proneness of manual operations. Actually, the auto-scaling evaluation involves numerous manual operations across different machines, such as launching benchmarks, registering scalars, and injecting workloads. However, introducing extensive human intervention is both laborious and error-prone. The third challenge is the inconsistent benchmark across evaluations. Runtime state of microservices is in constant flux because of cache, or persistent storage. Inconsistent benchmarks for each evaluation process will lead to unfairness across different auto-scalers. For example, systems' full databases are more prone to performance degradation. To address these challenges, we introduce ScalerEval, an end-to-end testbed that automates the key stages of auto-scaling evaluation. Considering the complexity of manual operations, ScalerEval weaves and automates these operations into an execution workflow, eliminating biases caused by human errors. To ensure consistent benchmarks across evaluations, ScalerEval proactively resets microservice systems and monitoring infrastructure before each test. Regarding the integration of autoscalers, we define a template and further provide sufficient fundamental interfaces, including observability and operability for target systems. We also provide basic visualizations for the collected metrics, facilitating further analysis of the result. In the following, we demonstrate how to evaluate our autoscaler using ScalerEval. There are 2 projects and 1 executable file in ScalerEval. The K8s dashboard project is the front end of ScalerEval, and the ScalerEval is the backend project. Before evaluation, you can update the exp_config.py and replace the cuba.yaml using the configuration file of your cluster. In the exp_config.py, you should adjust some configurations based on the actual details, for example, the URL of Prometheus. After completing all the configurations, navigate back to the project root directory and run the executable script build_run.sh. The build_run.sh script automates the process of building and running the front-end and back-end images. Now we directly launch this script. Since I've already built the images locally, this step completes quickly. Now, open Docker Desktop and you'll see 2 running containers, that is front-end and ScalerEval. Next, we enter the front-end container and wait for it to finish starting up. OK, according to the prompts, we open this link to visit the web UI of ScalerEval. We can see a welcome page of this web UI. This page presents the overall information of your cluster, including namespaces, deployments, pods, and corresponding YAML. You can also enter into a pod and check all logs of it. If you want to monitor the metrics of specific pod, just click it and you can see typical metrics of this pod. The ScalerEval button of the navigation bar in the left side and switch to the evaluation page. In this page, we can find several configurations that are common in auto-scaling, such as the benchmark, scalar algorithm, and workloads pattern. Now we select Online Boutique as our benchmark, and then evaluate the default Kubernetes horizontal pod scalars. We click the Start Evaluation button to clear and start up the benchmark. As shown in the logs, we can find that our tool cleared the environment used in the previous evaluation and then start a new benchmark. After the benchmark is started, we can click the evaluation button to inject workloads and register autoscaler. There are many logs about the workload injection and statistic results of all requests. We can also check the metrics of current pods. At the end of the evaluation, we can find that the tool delete the autoscalers and load injector. In the bottom of this page, we can find statistic results of this autoscaler, including SLA violation rate, success rate, and resource consumption. Click the Analysis button. We can further get visualization results of this evaluation, such as tail latency, throughput, CPU lines, and heat map. In conclusion, we present an automated and consistent testbed for autoscalers in microservices, namely ScalerEval. This testbed provides comprehensive interfaces to facilitate the implementation of autoscalers. That's all of this tool. Thanks for your listening.